demand is provided here. So this is a typical 25-day sales period. You can see the units of sales vary from, range from 3 to 10. So the question here is the demand distribution normal? So to determine whether a distribution is normal, its easier way is to check the mean, median, and the mode. Let's first find the mean. Mean means average. Okay. Average. Let's just select all the demand data. So on average, the daily sales is 6 units. Now let's see. Median. So it's the formula median. Data. 6 units. And the mode. So now, mean, median, and the mode are the same. Since mean equals median equals mode, it is a perfect normal. Now, what's standard deviation of demand? Okay. So let's give it a letter. Let's put it as a D there. Okay. What's standard deviation of demand? Let's put it SD, SD, standard deviation of demand. Let's put it here. So we can use an Excel formula. Since the textbook consider the data as a population, so then we use the population standard deviation formula for population, STDEV dot P. Select the data range. All right. So that's standard deviation. Now, is the lead time distribution normal? We look at the lead time table. So here is a 40-day period of distribution lead time. Looks like 16 occurring for a 12-day delivery. It occurred 16 times. For 11 and 13-day delivery, it occurred 8 times each. And for 10-day and 14-day delivery, it occurred 4 times each. So then, since this is a summary table, if we want to use formula, Excel formula, we need to convert it into raw data. So what we can do is say, let's say, put 10, right? So we can do copy 4 times. Here, 1, 2, 3, 4. For 11, we can copy 8 times. So this is 8 times. So for 12, we can copy 16 times. More. That's 17. Because the bottom indicator ratio count 18. See here. So then 13 expanded to 6 times. 6 times. 14 times. So now let's select the entire data. So that should be 40, 42. Looks like we may, so why is 42? Count, oh, so that's 2 more, that's no good. select everything, 40. And we're good. So lead time, no distribution normal, mean of lead time. So average (12 days). Feeding that's 12. Then mode. Select them. Also 12. Right. So lead time is normally distributed. Okay. Distribute. Standard deviation lead time. Here is the average uppercase mean. Let's put a T there. T. Standard deviation lead time. ST equals STDEV dot P. Select data 1.01. Okay. Here I want to point out that if we do not consider this data set as a population, if you just say forgot to add .p, what happens? Just stdev. Let's say stdev. Select the data. The Excel would consider this as a sample. The sample would have a slightly bigger standard deviation than what we treat is as a population. Okay, but that's not what we want. But textbook is for the consistency with the textbook. Now, 12E, what is the one standard deviation under combined uncertainty? So here's the formula, right? Combined uncertainty is square root of this 4 items here. T, SD, D, and ST. T means the average demand and average lead time. So let me add this inputs here. So T, we want to see the average lead time. Put it here. The number is this, 12. And D, let's put it this, average demand, which is here, 6. Then SD, standard deviation, daily demand. Let's expand a little bit. Yeah, okay. So this is right here. And ST, standard deviation of lead time. Have a number there. This is it. So our combined uncertainty, right? To this equals square root. All right, let's get more parentheses here. T, which is 12 times standard deviation of demand squared plus average demand squared standard deviation of lead time squared. Okay, root. Let's put that. Let me add a 1 row as a space. Oh, sorry, the other way. here. So this is pretty much like 909 units under one combined standard deviation. So question F, average inventory level at 3 standard deviations under combined uncertainty, given the Q. So now we know Q is 36 here. So order quantity is 36. All right. So basically what we're talking about here is the formula is Q divided by 2 plus 1 times combined uncertainty. That. Average inventory level is about 27 under 1 standard deviation, 36 units under 2 standard deviation, 45 units under 3 standard deviation. Find the function value of the normal loss curve Fk. We know that there is a relationship among Fk, SL means service level, Q is the order quantity, and the UC combined uncertainty. The K we can consider is a index. In this case, it's a normal loss curve function. So to find an Fk, we need to list all these numbers here. Let's organize the inputs. SL, that's 99%. And Q, 36. Combined uncertainty, let's use the numbers we just calculated. So then Fk. All right. So 1 minus service level times Q divided by C. So our Fk is 0.0396. Let's pick it four-digit level with decimal. Then we need to look up question H. Look up table 7.14 to find the value of K. Okay, so K, it's easy. Given Fk, it's 0.396. Let's find out Fk. So I'm going to share, let's see, a new share with that table. So we get an idea. See, open that table. All right, let's see, where is the table? Screen 1. Okay, let's see this. Right? See that table here? 0. Here, the text we use GK means the function of say let's treat it as FK. 0.039. 0.039. It's pretty much between those two values here, right? Let me use a pointer, right? Right here, it's between these two values. So we could, it's closer to 1.4, I would say this. Okay. All right, and going back to our Excel spreadsheet. So K is 1.4. Given K is 1.4, then our safety stock requirement would be 1.4 times combined uncertainty. So it's about 12.7 units. We can round up to 13 units. Now question I, what would be the required safety stock level if Q changed to 30 units? All right, let's do this. Let's put all the input here. We need to find out FK given that Q equals 30. All right, and let's say Q, in this case 30. And we still need it. T is 12. ST, which is 1.9. And average demand is 6. Asian demand since we already know that UC equals 909. Yeah, so we have that number. That's the input that we need. Q we need. Then SL is 99%. So our FK, let's just copy down our FK to here. So the new FK would be 1 minus 99% times Q divided by combined uncertainty. So our FK is this. 0.33. Let's find the table. What do we got? Table. 0.33. But 0.033. 0.033. I would think it's more close to 1.5. Yeah, very close. Yeah. So let's see this. Right. 0.33. Kind of close to here. Okay. Let me get back to Excel spreadsheet. 1.5. The point is, given the quantity, when quantity is smaller, right, the required safety stock would be greater. So that's a theoretical direction. Even though it's maybe not exactly 1.5, but we know that the K under this situation, Q30, is larger than the K under Q, it's 36. So then safety stock equals K times uncertainty would be 1.5 times 9. It's about, 1 unit more. All right. So this is the end of question 12. So I'm going to stop recording.